All right, guys, it's time to have an out-of-the-box conversation because our next speaker would like us to look beyond typical energy systems when considering sustainability. One single match in the darkness of eternity. Please help me welcome Aaron Kurth.
Okay, thank you very much. Really excited to be sharing some information today about this kind of interesting plan. I will admit that if I seem a little tired, I had my second COVID shot yesterday. So that might be why, but I'm going to try to bring a little bit of energy here and we'll see what happens. So I wanted to pick a little bit of a dramatic title that could maybe be a bit interesting. It also is pulled from something that I think is very impactful. So let me just tell you a little about myself. I'm a design researcher at a company called Delve in Madison, Wisconsin, but I work remotely out of Bloomington, Indiana. So of course, I used to be an engineer. I studied engineering as an undergrad, and that's where you'll see a lot of the content from today came from. I became really interested in this idea, and I think that technology has finally maybe come around where it could have an impact. And of course, that's me a little bit ago, a couple of years. So I wanted to, before we jump in, talk about 3 key points. There will be a serious energy crisis within our lifetime where we have a funneling down of supply or some other choke point where we're going to have to go beyond. We'll need to look beyond today's solutions. We've got a lot of great solutions today, but there's also things that we can do that maybe are a little bit beyond what we would ordinarily expect. But once we do that, society will be changed by an abundant energy source. So beyond sustainability, let's just think about where we are right now. We got really lucky as a civilization. The climate is just right, and generations of extinctions have placed basically free energy underneath the ground. And it's really rare that that happens because you need a mud layer covering dead animals and an anaerobic environment for oil and fossil fuels to emerge. And these aren't super deep below the ground. They're just accessible enough for us with our industrialized processes to get there. It's enabled us to go from just getting started with civilization to great progress over time. But at what cost? We know about this one. We know that temperature is rising and it's due to carbon dioxide. So future generations are going to have to pay the price for this. And if we think about the globe, not everyone has the same standard of living as people in the United States or Japan or Western Europe do. And most people probably do want that level of prosperity. So what are we going to do in 2050 when there's 10 billion people on the planet and energy use has grown much more than it is now? You can see this is a chart showing that by 2040, China will almost double, India will almost double in their energy usage. So this is going to be a serious concern to take a look at. And so let's say that we rely on our fossil fuels. That's where the title of this presentation comes from. One single match in the darkness of eternity means that if you look at the time scale from 4,000 years in the past to 4,000 years in the future, our use of fossil fuels, if we keep using them at the same rate, will be a little blip in time, like lighting a match, and that's it, and they're all gone. And so how can we maybe take a step that goes in a different direction than this? Renewable energy, great, let's focus in on that. There are some downsides to renewable energy. If you combine all the different types of renewable energy, it still won't meet the 2050 output that we need for if every person on the planet has a high level of prosperity. Photovoltaic isn't necessarily reliable all the time, same thing with wind. And really many of these technologies are a result of solar energy making its way to things that we can capture on Earth. But it's a patchwork of solutions that requires careful coordination and energy grids that are complex. And it doesn't quite have the capacity that we need. So let's think outside even the planet. The lunar solar power system is a way that this could happen. And the credit for this idea goes to a physicist, Dr. David Criswell from University of Houston, who has a ton of writing about this, which is a lot of what this is based upon. The moon is perfect for solar power. There's no atmosphere, there's no wind, there's no weather, there's no erosion. It's pretty inert. There's no water cycles raining water down on things. It's geologically relatively stable. There's a lot of empty space, and it's really cold, which makes electric systems work well. The moon is actually made out of the same materials needed for solar cells. So not only do we have space and we have the environment to do this, but we can take the lunar material and flatten it and then fuse it into a glass. And because there's no atmosphere, it's possible to take a layer to use that vacuum to deposit layers of material and build very thin solar cells on the moon. Great, so we have energy on the moon. How are we going to use that here? Is that even practical? We can send the energy back to Earth. If we used light, it would be the same situation we have now, where light is actually diffracted by the atmosphere. That's why the sky is blue. And so, but if we use the right wavelength, an infrared radio wave, you can have almost no power loss once it reaches the Earth. And then once it reaches the Earth, you'd have a receiving antenna that can capture it, just like a solar cell for electricity, but it's tuned for these specific frequency of waves. So these receiving antennas would be located near cities. There'd be low power transmission losses, so you wouldn't need to send energy miles and miles across the continent. These receiving antennas actually are somewhat transparent to light, so you can still use the space that they would take up for farming. And if they painted white, they would offset any heat added to the biosphere by the infrared radiation coming down, by reflecting the light that's already hitting them. So just to kind of summarize, this is what this system could look like, where we would have thin film solar cells. This is a concept from a Japanese company where they talk about putting a ring around the entire moon so that whichever side is facing the sun is able to absorb energy. So then we'd have energy transmitted back to Earth through radio waves and then reconstituted with about 90 to 98% efficiency going through the atmosphere. So that means whatever we collect on the moon, we're getting almost no loss once it gets to Earth. So this leads to this abundant energy future that is possible. There's a lot of space on the moon, and this would mean that we could have continuous energy in a localized fashion. So it'd be a simpler energy grid with little to no transmission losses because the distance is so short. And there's a lot of space on the moon to do this. So not only could we supply energy for the entire planet in 2050, we could supply more than what we need, which would mean that we'd have enough power for electric automobiles, enough power for other transportation systems, or who knows what else might be available that we could create if we thought about things from this abundant power scenario instead of kind of a lens of scarcity like we do now. And think about the different conflicts or different struggles that happen compared to what is happening that could be reduced compared to what's happening now. The other thing is we can start to reverse environmental damage, which we've begun doing, or which is happening with this surplus energy. So capturing carbon to reverse that process, automating recycling, or even making places that are becoming more arid have fresh water available. All of these are energy intensive processes that the excess energy could power. Finally, it creates a two-planet economy. So instead of just having the balloon of the current economy filled to what it is, we can essentially pump more air into that by having energy come from the moon, which means that we're decoupling the energy production from the Earth's biosphere. So we're not reliant on digging up coal or digging up oil and combusting those. We are able to use those for other things or save those for later. And so this would provide electricity at a really low cost level. Some have estimated at 1 cent or lower, 1 cent per kilowatt hour or lower. Finally, it's a springboard for space travel, where we would be able to save those fossil fuels for future use, save nuclear fuels, and then these beams can actually push spacecraft by providing energy and then powering their engines, at least in our solar system. So we can really think about this one match as a way to light the candle that keeps us going for a really long time. If we want to be really dramatic about it, in 5 billion years, the Earth will be engulfed by the sun. I know that's kind of crazy to think about, but until that, we have to plan that we will need to leave this planet someday. Until then, let's maximize our use of the sun and enable future generations to prosper. And it has to start with us, because it takes time to build these systems and to think ahead. So that's what I have. Thank you so much for listening.
No, but Danny did ask, what led you to this idea, Aaron?
Well, I mean, it's not my idea. It is David Criswell's, and I found it when I was in college, and I'm a big fan of how we can make, you know, the world better. I think we're all intrinsically that way as designers. So, and this seemed like kind of the biggest, craziest idea. But then once you looked more and more at it, it seems feasible. But the challenge is always, how do you coordinate that many people? How do you get that many people on board who could do this? So I'd love to, I would love to learn more about this Japanese company. It sounds like it's just an idea on their shelf, this lunar ring that they want to create.
Can you tell us more about the infrared power transmission? That seems like something that people have mulled over for a long time. That's from Carl.
Yeah, I mean, it's basically like, it's the same thing as using photovoltaics to send the energy down to Earth. And it's just a matter of focusing the beam in a specific location. So intermediate satellites would redirect that beam towards the right location on the planet. It'd be many different places along the planet where those receiving antennas would be. Was there more that he wanted me to dive into?
It seemed to be more about the infrared power transmission.
Mm-hmm. I mean, sometimes these are called microwaves. I tend not to use microwave because it has a certain stigma. And sometimes people ask about, oh my gosh, is a microwave beam going to hurt me? The way that this plan is designed, the power intensity is about 20% of sunshine at noon. And so it's not very intense. And you can kind of think about it, if one of these systems were built and you were to put your hand in the main part of the beam, you would just feel a little bit warm. So if a bird flew through, they'd feel a little bit warm. If a plane flew through the beam, they would reflect the microwaves.
Danny wants to know, do you think if you pitched this to Elon Musk, he would be a primary backer in addition to the Japanese company?
I wonder if it's a secret plan of Elon, because he's got his solar panel company, he's got his space transportation company, and he's got the customer base in electric cars on Earth that need electricity. So I don't see what's stopping him from 10 years in the future starting to do this.
And say, I know we're on a bit of delay, but I'm not seeing any more questions pop up. Is there any last minute thoughts or anything you want to kind of leave us with before we move on?
Sure. This is an unusual idea. I really wish that we could revive it, because thinking outside of just our own ecosystem and our own biosphere is going to be a huge thing in the future. And the sooner we do this, the sooner we can have those benefits. So if anybody wants to chat about this in the future, please connect with me, or just wants to connect with me. I'm good with that too. Thank you so much for the opportunity to speak.
Thank you. We do have one last comment from some Shamesh. I'm probably saying that wrong. I apologize.
Okay.
But this is an interesting concept for sure. I'm wondering if something similar can be done from orbit instead of the lunar surface.
It's a good question. The biggest challenge with space-based solar power is mass, getting mass into orbit, where you would then have it'd be really expensive to do from Earth. It'd be less expensive to do it from the moon, where you'd build the solar panels on the moon. But if you can build the solar panels on the moon and leave them there, then that is less expensive than putting the satellites out in space. Space solar power is quite similar, where you wouldn't need to put things on the moon. It would be these geosynchronous satellites. But the biggest challenge is that it's so expensive to bring matter up to space.
Nice. Interesting. Well, thank you again. It's wonderful. You left us with plenty of good things to think about.
Thank you so much.
Thank you.
Thank you, Erin.
Thank you so much.
Thank you.